All right, in this video, we're going to cover a couple of position versus time graph problems and one motion dot diagram problem. So we're going to be looking at the night textbook problems. And this first one is example number, or problem number 5, rather. Figure 2.5 shows a position versus time graph for the motion of objects A and B as they move along the same axis. For part A, at the instant t equals 1 second, is the speed of A greater than, less than, or equal to the speed of B? Explain. So if we're given position versus time graph, we need to think about how can I get speed from that? What am I looking for if I want speed? And if you remember from our notes, we said that the slope of a position versus time graph tells you the speed of the object. So we're looking at 1 second and we're going to compare the slope. So what you could do, well, A has a constant slope, so that value doesn't change, right? So there's the slope for A. And then at 1 second, which is right here, you could draw a line tangent, and that's the slope at 1 second for object B. And what you can see from that is that the slope for B is less than A. So the answer for part A is going to be speed of A is greater than speed of B. Okay, and the reason for that is because the slope of graph A is greater than the slope of graph B at 1 second. Okay, then part B says, do objects A and B ever have the same speed? If so, at what time or times? Explain. So they're asking, is there any point in time where the slopes are going to be the same? And that's definitely going to happen because you can see that the slope of graph B is constantly getting larger and larger and eventually is going to be larger than A. So we're just looking for, and we're kind of estimating here, at what point is the slope about the same? And so it looks like it's right around this area, right? Like if I draw a line tangent at that point, that's pretty close to the slope at A. And so we're just going to say yes for part B. And the time where they have similar slopes is around 3 seconds. So at about 3 seconds, the slope are equal. And that's it for question 5. Now we're going to take a look at question 7. It says figure 2.7 shows the position versus time graph for a moving object at which lettered point or points, and then we have a couple of things to look at. So for part A, at which lettered points is the object moving the fastest? So here we're looking for the point where the slope is as steep as possible, right? Because remember, the slope of a position time graph tells us speed. So we could just rule a couple of these out. So B is definitely not going to be an option because the slope there is 0. Okay, and then F, same reason. We can see that at point A and C, they're probably equal slopes, just one's going to be positive and one's going to be negative, but we're asking for speed, so the positive or negative slope doesn't really matter. So hopefully by now you can see where it's probably going to be the fastest at point D. Answer for part A is letter D. We're going to look at part B now. Is the object moving to the left? So which point or points is the object moving toward the left? So we're going to be, we're assuming that up is to the right. Okay, we'll just assume up is to the right, which means down is going to be moving to the left. So anywhere where you have a negative slope, you're moving toward the left. So that's going to be points C, D, and E. Okay, F doesn't count because you're not moving at all. B doesn't count because you're not moving at all. And at point A, you're actually moving to the right. Okay, let's look at part C. Is the object speeding up? So which points is the object gaining speed? This is a little bit tricky here. So remember that speed is the slope of this graph, right? So if you pick a point, the slope tells you the speed. So we're looking for the points where the slope is getting steeper. If the slope is getting steeper, that means that the velocity must be increasing, or the speed must be increasing. So anywhere where the slope is getting steeper, whether positive or negative in this case, that's going to be the points that we're looking for. So if you look at A, as time progresses, let's go ahead and get rid of some of this clutter here. If you look at A, the slope is getting less steep, so it's actually slowing down there and coming to a stop at point B. But then after point B, you can see the slope is getting steeper. So at point C, the object is still speeding up. So we're going to add that to our list here. Okay, if we look at point D, this is where it's actually reaching its maximum speed. We already said that for part A. So at this point, the slope is getting less steep, and so D is not going to be one of our choices here. If we look at E, the slope is continuing to get less steep, so E is not an option. And same thing with F. It's actually not even moving, so it's not speeding up. So our only point where it's speeding up is C. Okay, let's look at part D. Where is the object turning around? Where is it turning around? Okay, so if it's moving up, it's moving to the right. The line, if the line's going up in the positive x direction, the object is moving to the right, and if it's moving down, it's going toward the left. So where is it turning around? Definitely at B, right? So here we're moving to the right, we come to a stop, but then we start to go the other way. So B is a turning point. Okay, F is almost a turning point, right? We're moving toward the left. We're moving in the negative x direction. We come to a stop, but then we don't move anywhere. So we don't really turn around, we just stop there. So F isn't going to be a choice there. For part D, the answer is just B. All right, so now we're going to look at question 8. Figure 2.8 shows 6 frames from the motion diagrams of 2 moving cars, car A and B. Part A, do the 2 cars ever have the same position at one instant of time? If so, in which frame number or numbers? So remember with motion dot diagrams, we're pretending like this is a car that is leaking oil every second. So every time you see a drop of oil, that's 1 second that has passed. So we're looking for if these 2 objects are ever at the same position at the same instant of time. So first oil drop, that happens at 1 second, and you can see for A and B they're not the same. This second oil drop happens at 2 seconds. They're still not the same for each car. The next one happens at 3 seconds, and you can see that they do occur at the same point. So they are located at the same position at the same time. So for part A, do the 2 cars ever have the same position? The answer is yes, and that happens at 3 seconds. Okay. Part B, do the 2 cars ever have the same velocity at one instant of time? If so, between which 2 frames? So how can we get velocity from these motion dot diagrams? So the velocity is going to be the distance between the 2 oil drops over time, which is 1 second, right? So a larger distance means a faster velocity, smaller distance means slower velocity. So we're looking for the between which two frames do these have the same distance. Okay. But it also has to happen. So it says, do the two cars ever have the same velocity at one instant of time? So the point where they're going to have the same velocity has to happen at exactly the same time. Now, car A is moving at a constant speed. So as long as car B ever reaches that same speed, then we're good. So can you see between which two frames the distance between the oil drops is the same? That's going to be our answer. And it looks like the distance between these two oil drops is the same as for car A. So I can duplicate this and then bring this up here, and it does, right? So see how those are the same distance? So the answer for part B is going to be yes, and that's going to happen between frame, that would be between 5 and 6, or sorry, 4 and 5. 4 and 5 seconds.